Hello everyone. In this lecture series, we are going to read about different topics related to civil engineering and architecture. So, in this lecture, we are going to discuss about what is a development length and how can we find out the value of a development length. A development length can be defined as a length of reinforcement needed to be embedded or projected into another structural element to establish the design bond strength between the concrete and steel. So, what does this mean? So, look at here. For example, this is the beam. Okay, this is the beam here, and this is column. Yes, and okay, so this is beam and this is column. So here is the top bar of beam, and it goes like this, whereas the bottom bar comes like this and goes upward. This beam element 1, and this is element 2. So this is element 1 and element 2. Element 1 means beam, whereas element 2 is column. So this is two structural element. So the top bar, or you can take a bottom bar, you can see here development length is the length needed to be embedded or projected into another structural element. That means the length needed to be projected to another element to develop the full strength, full bonding strength. So that means this length is development length here. This is L, which is development length. So we can find the code provision about this length in IS 456-2000. You can see here the development length of bars can be determined by this equation. So actually this can be derived theoretically as well. In we can as well in we can use many references, for example RC books of by Subramaniam and many other books. We can calculate, we can just derive these equations, but for now we are just going to use this one. So here, so the equation is LD equal to phi sigma s for tau BD. So LD is the required development length, Okay. So phi is the diameter of bar diameter. Likewise, sigma s is stress on that bar, Okay. And the last one, tau BD is bond stress, design bond stress, okay. Design bond stress. Okay. So we can find all the values of this one. This is the diameter of bar. Sigma s can be determined as like this. You can just take the maximum permissible stress, or you can calculate the exact stress that comes to the bar. If you don't know the exact stress on that bar, you can just assume the total maximum stress that is permissible for that bar. That value is sigma s equal to 0.87 Fy, where Fy is characteristic strength of steel, and generally it depends on the type of bar. Yeah, generally we can find in the market there are three types of bar: Fe 250, and the one is Fe 415, and the last one is Fe 500. So generally we use Fe 500 in most of the cases. So we can use for Fe 500 bars, Fy is 500 Newton per m square. Okay. So you can put the value here. That is 0.87 into 500. That is 0.87 into 500, 435, 435 Newton per m square. Okay. So we know the diameter of bar, and we have calculated just the value of sigma s. Then the design bond stress tau BD value can be seen in the table which is provided on IS 456-2000. So just we'll go to that table, and here is the table. So it depends on the value of concrete grade. Okay, so depending upon the different grade, for example, M20 grade, the value of the bond stress tau BD is 1.2. Similarly, for M25, its value is 1.4, M30 1.5. For example, we in this case we are going to use M25. So tau BD for this case is 1.4 Newton per mm square. Okay, let's put all the values on the main equation. LD equal to 5. Let's just take phi as a 5. We can just change the value of phi later, and we have just calculated the value of sigma Yes, that is 435 and 4, and tau VD is just 1.4. Okay. Also, there is some modification here depending upon the characteristics of the bar and whether the beam is compression member or not. So, if the deform bar is FE 415 or 500, we can just divide it by 1.6 further, and if this development length is calculated in the case of compression member, we can also divide this value by 1.25, but we are not going to use that. It's for a beam, so we will not divide by 1.25. So this is the value of LD, and it gives equal to just 435 divided by 4 divided by 1.4 and 1.6, so which gives approximately 49.5. So this is the equation, this is the formula for calculating development length, and we can calculate the development length for different value of bar or diameter of bar. For example, development length for, we can do like this clearly, and 5, for example 12 bar, we can just multiply 49 by 12. That will result 49 into 12, that is 588 mm, which can be used as approximately 600 mm. Okay, like this, because we can calculate another one, 46 for 46.5, it is 49 into 16, that will result 49 multiplied by 16, so it is 784 mm. So just round up this one, that is 800 mm. Okay, so in this way we can calculate the value of development length for different size of bar. So if we use this length here, so this is the development length for beam column connection, this is LD. Okay, so if this is 16 mm bar, then we know that the value of LD is 800 mm approximately. So just we have to insert bar in such a way that the length is at least 800 mm. Okay, so this length is at least 800 mm. So in this way, using equation provided in IS 456-2000, we can calculate the value of development length regarding the concrete grade strength and diameter of bar.